Thank you very much for inviting me again. I really appreciate this. This is the second year, I guess, I've given this talk. I've been involved in doing seasonal forecasting now for about 6 years now, and have worked on kind of trying to, improve on the technique as the years progress. I also hear that maybe old colleagues, Pete Pugelum, Brian Stocks might be on there. Greetings. Long time no see. Before I proceed, I thought maybe it might be worthwhile going through an introductory talk. It's a very short talk, but it kind of covers fire danger rating in Canada. It gives a bit of the background behind some of the science, what we do, and the fire the fire situation in Canada, how fires behave on the landscape. So this is a short talk, but worthwhile. So just as an introduction, typically in each year in Canada, we typically see about 7,000 forest fires. These will typically burn on the average of about 2 million hectares, a hectare being about twice the size of a football field. And $250 million is spent fighting forest fires each year. The business of fighting forest fire is a provincial jurisdiction, as well as federal for Parks Canada and D&D. Forest fires typically are primarily caused by people. About 2/3 of forest fires are caused by people through recklessness, campfires, occasionally arson. But what's also interesting is the fact that about 87%, which is about 5/6 of the area, is burnt due to lightning-caused fires. Why this discrepancy? Well, that's because lightning fires tend to occur in remote areas and are more difficult to catch at the very start, and hence they tend to get bigger. Also, they'll occur in larger numbers. People-caused fires, on the other hand, will often occur around a community and are quickly reported and quick to contain. Large fires, there's a large annual variation in the numbers of fires in the area burnt, as you can see on the graph on the left. The bars indicating the area burnt, so there's a wide fluctuation in the amount of area burnt each year. The black line is indicative of the numbers of fires. And in the bottom right, we see a picture of Canada showing that most of the area burnt typically occurs in the boreal forest. And this has to do with the fact that the forest tends to be more of a continuous fuel type. And the coniferous trees there are more conducive to fire activity. If anyone in the room has any questions, you feel free to ask. Also, what's of interest is the social trends, and we're seeing here in this graph here is a percent change. We're seeing that the largest net increase in population is in what we describe as the rural metro adjacent region, and this corresponds to what we've called the wildland urban interface. And a lot of this new population consists of non-permanent residents, so people buying recreational properties and whatnot. And even though insurance payments are low compared to other events, and of course this doesn't reflect the recent events that happened at Slave Lake, but does capture Kelowna. Though insurance payments are small compared to things like flooding and ice storms, we may see an increase in these payouts as social trends move people more out into the rural areas, as well as possibly due to climate change. But then we have to back up and consider the fact that fire is a natural part of the landscape. indeed coniferous trees are dependent on fire. They need the fire to come through to open up the forest to provide light for the new seedlings to grow. Fire opens up the understories for foraging animals. And frequent fires prevents a buildup of dangerous flammable understory. I always like to draw the analogy of firefighting, and it's sort of like stretching an elastic, because the farther you stretch it, the bigger the snap when it breaks. And what's happening is fire is a natural part of the landscape, and the forests need the fire to kind of keep healthy. And if we're always fighting the fires, eventually you end up with a dangerous buildup of fuels on the landscape, which can result in more catastrophic fires. So this is the dilemma in fire management. How do you balance the ecological benefits with the loss of valuable timber and the threat to human habitation? So as our part in this, the Canadian Forest Service has worked in the development of what we call the Canadian Forest Fire Danger Rating System. And it's a very helpful tool to fire managers to help predict the fire danger in the lands in Canada. The Forest Fire Danger Rating System consists of 4 components. The Fire Occurrence Prediction System is always a bit of a kind of a moving target. We're working towards developing systems there. But we've got the Fire Weather Index, or FWI system, which captures what the fire conditions are out in the forest. The Fire Behaviour Prediction System that helps predict specific fire characteristics. And we're also working towards developing the Accessory Fuel Moisture System. So this is perhaps one of the most familiar products that the Canadian Forest Service has developed over the years, the FWI system. Every time you drive into the parks, first thing, often you see these signs indicating the fire danger is low, moderate, high. Well, that's a model that the CFS developed over 40 years ago. And it's a national system, so fire danger in Halifax is the same as fire danger in British Columbia. And it uses the same system. It's based on noon weather conditions, and it helps to predict what the fuel moisture is, how dry the forest floor is, for example, as well as the potential fire behavior. More recently, we've developed what we call the FBP, or the Fire Behavior Prediction System, which is more stand specific. It actually gives you physical parameters, how intense the forest fire is, how fast a fire will burn. And this is dependent a lot on the specific tree species, or fuel types, as we call them. Now, what we've done in Edmonton is we've developed what we call the Canadian Wildland Fire Information System. This is an internet site, a web-based product that presents the fire danger conditions across Canada. If you want to find this site, you can try to decode the URL, or you could just simply go to Google and type CWFIS, and I guarantee you it's going to be the first or second thing that pops up. Again, what the CWFIS does is it takes the weather conditions across all of Canada. About 2,000 weather stations are fed into this, feed their information into our system. And we end up taking that information and plotting the conditions across all of Canada. Likewise, we have maps showing us the various tree species across Canada, so we can feed this into the Fire Behavior Prediction System and predict, for example, on this map showing how intense a forest fire would be. And another component that we now include is the hotspots. We've got satellites that are orbiting the Earth with infrared cameras on them they're actually able to detect larger fires. And this information is presented, is collected and presented on the CWFIS as well. So in summary, the Canadian Forest Fire Danger Rating System is a national system and has been used in Canada for over 40 years. And the CWFIS is a platform to present this information to the public. Yes?
For those maps, it's my understanding that you update the maps daily on the web.
Yes.
Is it possible to keep past maps?
Yes, they're all archived on that website.
And you could produce an average map in the last 5 years or 10 years?
We try to do that.
Are those available on the public or on the web or anywhere?
Yeah, actually, I think we've got some climate normals sitting on the website as well, but those are old. We're in the process of updating them. Typically, one kind of climatologically speaking, one looks at a 30-year window. Yes.
Sorry.
That's fine.
My next question is, do you give that to other parts of the government? Like, does DND have your maps, and does, for example, the Building Code Commission have your maps about fire risk at different parts of the country?
We've worked with DND, with Public Safety Canada. This information, and as well as provincial agencies, this information is available on the web. We haven't scoured through all the various nooks and crannies of the government to figure out who might be able to use this, but it is available, and we try, hopefully, through presentations such as this, reach out to newer audiences. And yes.
There's one other question now.
Sure.
When someone goes from, like, when you have your map and you have your dots, I assume, I guess that's a couple questions. Each square on your map is how big?
If we go back a couple slides here, these are typically 1 kilometer in scale.
Okay.
I think where you're going to is this.
Well, I'm back to the blue and the...
Okay.
So on your map, if someone went from blue to yellow or yellow to orange or orange to red, do you tell them? Like, do you have a way to say?
No, we don't have a process set up that way. Again, it's worthwhile to remember, and these are good questions, I should say. Perhaps people in the telephone audience are thinking the same questions, so I'm glad you're bringing these up. It's worthwhile to remember that the actual business of fighting forest fires is a provincial jurisdiction. So often many of the provinces have systems like you described kind of set up, whether it's in fire bans or alerts that are issued through the radio that the fire danger conditions are high. Provincial agencies are managing that. What we try to do with the CWFIS is present a national perspective, and helps to kind of get provinces talking with each other as well, so that people in Alberta will know what the situation is in Quebec and why Alberta needs more air tankers, and resources are often shared between the provinces, so it's good that they're all talking a common language, I guess is where I'm going on this.
Yeah, sorry, I just have one question.
Yes.
If you go back a couple of slides there, you have the actual, ahead again, the fire weather. So that's daily fire danger, so that's sort of an important map if you're thinking about risk.
Where I'm going, I should explain. This is just a quick overview. The difference between the fire weather and the fire behavior is this is a generalized system that looks specifically at just the weather. It was actually an earlier system than FBP, but the FBP system tends to provide more detailed information, but perhaps more information. So it's often easier to work with the FWI system as a more general system across Canada, because that even though that park sign says extreme, as you move from the grasslands into a deciduous part of the park and then into a coniferous, FBP would suggest that you're going from high to low to moderate. You know, this is more detail than the public may need.
Right.
A fire boss will want this information, but
this map is like a layer of both weather and fuel type.
And fuel type, yes.
The other
tree
map
species,
is just weather.
Is just weather.
Right. So it's the second map that's the more useful thing in terms of, say, if insurers wanted to estimate risk.
The insurance people should definitely be considering fuel in their underwriting, or I'm not too familiar with the insurance business. And certainly this is captured within the Fire Smart program. So, and I understand that some people from Partners in Protection have been talking with you, and I encourage that dialogue between your two groups, because while this is information you may find useful, it's also information on a national scale. And it's hard to judge if that's going to affect a specific house. So that's something to keep in mind.
Just sort of when we're following from what Grant was saying about sort of overlaying maps, because when you look on the website there, you sort of have maps from 2003 on, and they're daily. If you took all those maps and just overlaid them in GIS or something, it might give you sort of areas where historically there's been more high-risk data.
What you're describing is a topic called how do you describe it? Wildfire threat analysis, and certainly people have been working on these projects, and yeah, it's a good point to bring up.
That's a useful thing. Like a fuel changes year in, year out, wouldn't it? So your fuel stand would be different now than it was in 2003. So is that a useful thing to take all that historical data and lay it over each other to produce a risk?
Oh, yeah, certainly. Certainly that would be a benefit. Yes?
Yeah, just saying, it could be if you take that, but the problem is when you start doing overlay analysis in GIS, you can really start introducing a lot of error by doing that sort of thing, so you have to be very careful in checking year by year mapping to make sure you're actually comparing sort of apples to apples. Right. Otherwise, you can end up with a map that looks pretty, but really doesn't have much, much validity.
Right. Yeah. If you want, we can, I can pass along some information on this topic to you when I get back to town.
Sure. Yeah.
But yeah, people have been doing this sort of thing. How are you doing? Any other questions? Because that's pretty much, you missed yeah, that was the last slide. Okay, if there's no other questions, perhaps I'll just move on to the next talk. Do I just reach over here and why don't I get you to drive? Sure. So again, just to recap, if you want to see these maps, and all you have to do is do a Google search on CWFIS. It's worthwhile noting that I'm not too sure if it's active right now. Montreal, we get a lot of our information from Environment Canada in Montreal, and they've been providing us with 2-week forecasts. But I think they kind of did a change on us, and we're trying to fix our system to conform with their new data format. So, anyways, the reason why you brought me here is to talk about the seasonal forecast. Again, what I've been doing this since 2006 was a technique that I kind of came up with. Basically, it goes through this methodology. First, starting out with the calculating the spring startup conditions. This is we take how much what it was like in the fall. We consider how much snow fell over the winter to figure out what the conditions are like in the spring. Second, independent of number one, is we calculate the average daily weather for a number of weather stations across the country. I think we've got over 200 weather stations we do this for. Then we get the seasonal forecast provided to us by Environment Canada. This is a product that they've been presenting over the years, and we've tapped into that and are now using it for fire weather forecasting. Once we get the Environment Canada seasonal predictions, we apply it to the daily average weather conditions for number 2 to calculate the fire severity rating over the month through what we call the monthly severity rating. Next slide. So this is visually showing you what we do. Step 1, we look at the conditions in the fall to calculate what the conditions in the spring are like. Number 2 is we look at the average daily weather for a station, in this case Edmonton. We take the seasonal forecast that Environment Canada provides us. In this case, they come to us as ensembles, which is a meteorological technique. I'll try not to get too wrapped up in, but we end up with a number of predictions. And we apply that to our average weather, and ultimately, if we do that for our 200 some odd weather stations across the country, we can interpolate those conditions to provide maps showing the forecasted fire anomaly. Ensemble forecasts. This is a popular technique in meteorology now. The idea is essentially we don't know with 100% accuracy what the current weather conditions are. Because weather stations are 30, 50 kilometers apart, we don't know what the weather's like in between. Also, there's errors in measurement. So the idea of ensemble modeling is to add a bit of that fuzziness and that kind of uncertainty. And they end up running a series of forecasts. So instead of running a weather forecast out for the next 5 days, they'll run 10 or 30, or in the case of the North American Ensemble Forecast System, they run 40 model runs, where they jiggle the starting conditions. This is a popular technique, and this is what they're using in seasonal forecasting. As you can see here, we've got 4 models that they're using. This is actually in the process of being changed, but for the purposes of this talk, we're using these 4 models. And the forecasts are provided for the next 4 months. So this is what an ensemble forecast looks like. Again, you're getting this multiple weather forecasts. So you get an indication of how the weather is going to change. Here in Edmonton, you can see here that the prediction is actually showing above average conditions for temperature for practically all the ensemble members except for some for the month of July. Likewise, on the right-hand side, we've got the predictions of the precipitation. And again, we're seeing that a majority of the models are actually showing below average precipitation in this case. This is for this year.
The average is the black line?
The black line, oh, sorry, I must be reaching through. My voice is cracking. The black line here is the 30-year average. Okay? And so we get these forecasts as anomalies, that the forecast is predicted to be 1 degree above average. So we apply that to the 30-year average weather and get one of these squiggly lines. We've got an ensemble, we've got 10 members now in the ensemble, so then we get 10 squiggly lines. In this case, we've got 2 models that we're running, so now we've got 20 squiggly lines. And this is how we're getting our forecast. The nice thing of ensemble forecasting is when the models start to disagree with each other, you start to see the forecast spread. Or likewise, when they start agreeing with each other, they tighten up. So in this curious case for the month of June, we've got one model that's actually increasing its uncertainty, while the second model is actually increasing its certainty. So, but this is technicalities maybe.
Yeah,
Yes.
I think here that uncertainty and error are two different, slightly different concepts here. What's the actual error in these? Because as you start putting several models together, you have to take the error from each of the models and it becomes additive. But is that, at that point, are you concerned about that, or are you just basically saying this is our best guess?
Well, actually, when you're doing multiple measurements, you're actually decreasing the amount of error, because you're coming up with an average. If you want to know what the weather is outside at a given moment, you go out with the thermometer once and you say it's 10 degrees. It's probably 10 degrees plus or minus 2 degrees because you had it in your back pocket, and, you know, all sorts of factors. But if you go out a bunch of times, if you go out every minute and measure the temperature, measure it again, you actually end up decreasing the error through multiple measurements.
Okay, so that each of these ensembles are multiple measurements, they're not just different modeling techniques.
They're the same model, but with slightly modified initial starting conditions, is what they are.
Oh, okay, I see.
Because we don't know with 100% certainty what the initial conditions are. Now, there are different approaches to ensemble forecasting of running different models with different kind of physics driving the models. So you can see if different modeling approaches produce the same results. But anyway, this is a fascinating topic.
No, I understand what you're saying.
That we could talk for, I've got other talks, that we can, but I think we'll bring this back to, let's chat more about this later. So just coming back to this, what we're doing is the ensemble approach actually gives us an opportunity to get a measure of the confidence of the models in their forecasts based upon the spread of the individual members. So the first thing that people always want to say is, well, how is your model doing? How did it do last year? Well, that's what I'm going to do. I'll just cover briefly how this worked out last year. Okay, last year, as it turned out, was a relatively normal fire season with a below normal, below average number of fires, but above average area burnt. So you can see the numbers down below. It only experienced 4,500 fires. Typically, we see over 7,000, but area burnt 2.5 million hectares compared to an average of 1.6. So about 60% of the fires, but about 60% above average area burnt. And most of the activity occurred in northeastern Alberta in May, and in Ontario in July. In May of 2011, we saw severe weather fire events happen, and on May 15th. Strong winds gusting as much as 70 kilometers per hour, combined with a lack of precipitation, created extreme conditions over much of Alberta. On that day, there were 68 new wildfires reported between Saturday and Sunday the next day. And these events ultimately led to both the Slave Lake Fire and the Richardson Fire. And this is a satellite image provided by NASA showing just the numbers of fires. This small little insignificant one burnt down Slave Lake.
Kerry?
An insignificant looking one.
Right.
Yes.
So, interesting, I find anyways, that the fires in 03 in BC came on the heels of extraordinarily dry
Conditions, yes.
over a long period of time. And
Yes.
to a layman, you would think that you'd need drought for fire. But this was not the case in Slave Lake. It was a normal winter, normal snowpack. Wasn't extremely dry. It was just 3 days of low humidity and off you go.
Precisely.
Can you comment on that? I mean,
This is what this slide is actually doing. I had a chance before I came here to go to the province, and I talked with Nick Nimchuk, the provincial kind of head of the weather section there, and he gave me the lowdown. Essentially, the conditions leading up to the event in Slave Lake weren't weren't exceptional, as you're pointing out. There was actually snow on the ground a few days before this fire broke out. But what happened was it was a combination of high winds and extremely low humidities, and this led to an explosive situation. Fire can either burn fast, which is indeed what happened in Slave Lake, when all the fine fuels, all those dried grasses, all those light fuels that could dry very quickly, that caught fire, and that launched the fire, into the town. Or fires can burn deep, depending upon how dry it is. Now, in Slave Lake's situation, I don't think it was the deep fuels weren't very dry, but still, it was a very fast-moving fire, and that was enough to throw this fire, sparks flying into the town, and causing this event. The Richardson Fire. This is another fire that occurred on the same day. And the interesting thing about this one is it was happening in the north, and it turned out it did an 80-kilometer run in about 48 hours. This shows you the power that fires have. Now, as it turned out, it was heading to the north, so it was less of a concern. And it was burning into kind of areas that they had their hands full anyway. Ultimately, this fire burned over 500,000 hectares, about 5,000 square kilometers. That's about 20% of the area burnt was due to this one fire. Also of interest, you'll see from this satellite photo, is all this activity that's happening just south of the fire. That's the oil sands. Naturally, it was a priority for the province to fight the fire on the south side to prevent it from moving into the oil sands. But one can't wonder, if this fire ignited south of the tar sand or oil sands instead of north of it, what could have happened? July we saw extreme fire season in Ontario, with the most area burnt in over 50 years. And in 2011, there were 1,200 fires burning 600,000 hectares. 10-year average for Ontario is about 1,000 fires burning about a tenth that number. What happened in Ontario that year was that we ended up with kind of a weather pattern where the system sort of split, where storms are tracking north of the province or south of the province, and Western Ontario was kind of not experiencing much of the precipitation. But when you combine that with the lightning activity, it caused a lot of ignitions that got out of control. So this brings us back to my seasonal forecast, which I would have presented last year at this time. And you would have seen these same four maps. What does this show? Well, we're actually showing what appears to be below average conditions in kind of a light blue for much of Western Canada, and into May we're seeing that through most of the prairie provinces in Western Ontario. As we move into June, we're seeing an above average area in the northeast where the Richardson Fire occurred, and we're not really seeing anything substantial in Ontario. And in July, we start to see the conditions increase. Now, I do these forecasts once a month, so it's interesting to see what my May 1st prediction looked like. And again, we're seeing this area in northeastern Alberta where the Richardson Fire occurred, as showing as above average. But what we're not seeing is the events in Ontario. And finally, as we move into my June 1st prediction, we start to see most of the country going into above average conditions, which is actually contrary to what actually happened. Most of Canada kind of slipped into saw an end to their fire season in June and July. and here we are showing up with above average conditions. But in my defense, I'd like to say that when we're looking at maps of August and September, what these maps are showing is above average, but one has to step back and think, well, what are average conditions in September, you know? Actually, they tend to be cool and not very conducive to fire to begin with. So the August, September maps tend to look redder than they normally should. So in summary, 2011 was a relatively normal year with below average number of fires and above average area burned, and indeed 20% due to just the Richardson Fire alone. The model predictions did point out the area in northern Alberta as being above average, but failed to detect the situation in Western Ontario. And I think that had a lot to do with the fact that the seasonal forecasts aren't predicting individual weather events, but are predicting more the general average conditions. Also, what I'm seeing is perhaps the model is a little bit kind of, and indeed we were, kind of struggling to find where's the fire season happening here. And maybe what the model is trying to do is it's trying to tell us it's looking like a pretty normal fire season with just slightly above, slightly below conditions. Maybe, okay? So if we move on, we move into the 2012 predictions, and we look at the starting conditions. So fire conditions, the drought code, we look at the fall drought code, and we calculate the amount of snowfall that lands over the winter to figure out the spring conditions. And all the other FWI systems are reset. So these were the conditions in the fall, October 1st, showing large areas in Western Canada that have high drought code, extreme drought code conditions, which isn't really too abnormal for Western Canada, but they are significant. The North American drought code indicates a relatively normal pattern, with the exception of parts of Alberta described as in extreme drought. If we apply the overwinter snowfall, we get starting conditions that look something like this. And I pulled this off the CWFIS a couple days ago, April 9th. And it's showing much of this, as the snowfall retreats, as the snow on the ground retreats, we're seeing a lot of the area in southern Alberta, southern Saskatchewan, and Manitoba being and Western Ontario as being above average conditions. Indeed, if we look at the spring startup conditions on various other years and compare the two, we see that this pattern hasn't really shown up except in 2004. And in 2004, we burnt down 3.1 million hectares, about twice the annual average. So there's a red flag there. Now we look at the products that CMC is providing us. Well, they provide us, they're giving us data in monthly values. They tend to present the information on the web as in 3-month periods. So we can't quite see it on the screen here. It's just a little bit below. But for April, May, and June, the map is showing above average temperatures for much of Canada west of and including Alberta, excluding the NWT. Also, we're seeing below average precipitation amounts shown in the blue for much of Canada. The bottom half of the maps, which probably ties into what you're discussing earlier, is again the confidence in these forecasts up here. The seasonal forecasts have always had trouble with precipitation. It's very difficult to forecast, but you can see here that they're very confident in the above average temperatures. Also, what's worth noting is that the areas that they have confidence in Alberta and Saskatchewan and Manitoba correspond to these below average precipitations. As we move more into the summer, in this case May, June, July, we see this above average normal temperatures increasing to cover practically all the southern, all the provinces, but not including the territories. Likewise, for precipitation, we're seeing most of the western, well, basically from Ontario west, is having below average precipitation. Confidence is moderate for some of these areas in question. Finally, as we move into the late summer, into July, August, September, we're seeing practically all of Canada within the tree line, south of the tree line, as having above average temperatures. And practically the same area, with the exception of Atlantic Canada, having below average precipitation. Again, as we move deeper into the seasonal forecast, confidence drops down. No surprises there. So, we got another red flag. 2012 predictions. So if we take those two pieces of information and feed it into our prediction system, we're looking at this, okay? So for the month of April, the map is showing a large area of Western Ontario. This is the area that experienced extreme, fire activity last year. We're seeing it showing up again in the spring. Also, we're seeing Manitoba and Saskatchewan as being above average. Quebec is above average too. On the left-hand side is again the confidence. So it's interesting to note that although it's predicting well above average conditions, the confidence is not as high. Likely the models are just, it's indicating the spread in the predictions. As we move into May, we actually see the well above average areas kind of retreat more to southern to southern Manitoba, but still much of Canada west of Alberta is still in above average conditions. Confidence is lowest in southern Saskatchewan. And you'll notice that the confidence patterns tend to repeat themselves. They tend to be highest along the coastal regions because oceans tend to have a moderating effect, and continental climates are more unpredictable. As we move into June, we see sort of a split where below and above the 60th latitude, we're seeing above average conditions. Again, the confidence is not too high in this as we move deeper into the summer. And finally, for July, we're looking at some well above average conditions for southern BC and much of Alberta and Saskatchewan and Manitoba. So this is a concern. Now that's another red flag. Okay, here's something else. In December, the Canadian Meteorological Centre has decided to change from one forecasting system to another, where they're now using two models from the Canadian Climate Centre models, where they're using the general circulation models 3 and 4. These promise to be better models. They're coupled with sea surface temperatures, so they're actually catching a lot of the El Nino effects better, and they're promising to produce better long-range forecasts. And these forecasts will actually go out for the next 12 months. So this is a very positive thing for my modeling, to be able to start in March and be able to forecast for the whole fire season. So this is what it looks like. A model that's basically promising to provide better predictions is getting even more extreme. Okay, and if we compare it to what I just showed you, you'll notice that the patterns, I'm just switching back and forth. The regions are being consistent, but the extent of this red, well above average area is expanding dramatically. And so this has got me very concerned, okay? We may indeed see a very extreme fire season this year. Up until my experiences so far have been kind of average to above average fire seasons over the last 5 or 6 years I've been doing this. This is starting to show up as probably the most extreme I've seen. Now, we saw similar sorts of forecasts before in April, and then a weather system came by and just drenched the whole country, okay? Which kind of like just rebooted my weather forecast. But going by, oops, sorry, I'm trying to get back here. Going by what information Montreal Environment Canada is passing on to me now, this looks like it's shaping up to be a pretty bad fire season. So in summary, I just want to say indications are that Canada could experience a dramatic fire season this year. Let's go through, let's walk through these. Dry conditions in the fall throughout much of Western Canada. An unusually warm winter. Remember all those news reports about temperatures in Winnipeg being 25 degrees in March? Okay, this sort of stuff. And combine that with Montreal, the Environment Canada's forecast indicating that temperatures are going to be above average. Well, precipitation is expected to be below average throughout much of Canada. But the caveat at the end, of course, is that seasonal predictions are at best an indicator of how the season may develop, okay? I can't provide, I can't provide 100% confidence in these forecasts, but obviously it would be very prudent to be prepared. So at that point, I'd like to close the presentation and open it up to any questions in the room. Also, I should maybe put forward that if anyone is interested in talking to me about this forecast, for those that are on the phone, I'm sure there's contact information that people can reach me, and I'd be more than happy to discuss this in more detail with you. So again, as I said, I open the floor to questions. Yes?
Two things. First of all, in last year's season, not only did you sort of get a smaller number of fires, but a larger number of area, but you also seem to have gotten a odd geographic spread, and so much of it was concentrated in Ontario.
Yeah.
So you get sort of a really, it seems average, but it ends up really weird in some ways.
Okay, that's an interesting point to bring up.
Because you're getting another anomaly thrown in on top of it, it seems.
It's actually not that anomalous. I'll put on my Claire Martin hat here for a minute. When you're watching the weather forecast on TV, Claire Martin or whomever, goes up there, and the first thing they start to describe is the jet stream. And they show this jet stream that goes up, and then it goes down, and goes. Those are what we call Rossby waves, or planetary waves. And there's a certain kind of number of these, typically 5 or 6, that encompass the North Pole at about our latitude, Canada. Canada turns out to be about 1 wavelength long. So planetary waves, what are planetary waves? Well, these are all the highs and lows. They're always going up and down these things. A ridge is generally associated with warmer weather, with drier conditions. Well, a trough will typically be where all the cooler weather is and all the rainfall. So where this is going is, Canada is approximately a wavelength long. You're almost always going to see one part of the country in extreme warm, hot conditions, while the other part of the country is in cooler, wet conditions.
You're always going to have a concentration somewhere.
Yeah, and it's just going to move around. So again, tying into your question, you commented on how all the activity was happening in Ontario. Well, it wasn't happening in Alberta or rest of Canada. Well,
earlier.
we had a cold, wet winter in Alberta. Why? Because of this pattern. And it's quite likely that Atlantic Canada similarly experienced a cooler, wetter summer. I could, I'd have to check, but that would be my initial guess.
And
that answers your question?
Yes, that answers the question.
Okay.
The other thing is with some of your prediction maps, I noticed there were a couple of places, especially in the east, where you had a high potential for fire. They were fairly small, but there was a high potential, and there was also a high confidence rate. Would that be something you really have to worry about? They were small, but they seemed to be there.
These sorts of maps, or?
Yeah, I think they were before there. I don't remember the exact
Or
one.
were you looking at the ones from last year?
I think it was the ones for this year. I don't exactly remember.
Okay, if we look at these guys in more detail, you're interested in areas like the confidence is very high
Yeah.
in what appears to be the Paw,
Yeah.
Manitoba, and also very high in Grand Prairie. Well,
And I think-
this is the 200 weather stations kind of peeking through. So that's why we end up with little bullseyes like that.
And they
You
go up
also
above
notice
average
that-
as well.
You'll notice that Dawson Creek, just 100 kilometers away, is below average of confidence. Hard to say exactly.
So I'm just saying, when you get those intersections, should you be very, very worried because you've got a high confidence and a reasonably high severity?
Yeah, that would certainly be the areas you'd be most interested in. Not so much the bullseyes, as much as just areas where the confidence is high in an above average conditions. See, so when I'm looking at this map, I'm looking at a lot of Ontario being perhaps in low confidence. But again, what we're talking about is spread of these ensemble predictions. And it might be that they're all high, but the spread is wide. So yeah, you could kind of really get tangled up trying to understand all the different things going on here. But I have the ability of looking at the individual time series. Like you saw my forecast for Edmonton at the beginning of the talk, I can look at these things in more detail. If there's anything that you're interested in, I can I can show them to you as well.
That's fine.
Have I answered your question?
Yes, you did.
Getting distracted here. Any other questions? Yes.
Does anybody keep a list of interface communities in Canada or top at-risk interface communities in Canada? Part of my thinking is that the census just came out. It would be interesting to compare growth of these communities and values and at-risk areas and that sort of thing. So on top of talking about changing the hazard maps over to risk maps, it would be interesting if we knew some of the communities that are higher risk.
It's an interesting question. It's also a bit of a sensitive question too, because obviously this impacts on individuals. I'm not in the position, I'm not aware of such a data set, but I think there are people working in that direction. I know that there was a publication by a former colleague of ours, Jen Beverly, that kind of documented some of this stuff. I know that we've been in the process of keeping media reports, scanning the newspapers for reports of evacuations. We've been building up a database of that information. But future communities that may be affected in the future, it's hard to say. I'm kind of walking on thin ice talking about this stuff. So. But I believe there are people working in that general direction. Yes.
I have a memory of, it's probably about 5-6 years ago, we drove around north side of Lake Superior, and there's one section there where it seemed to be like for an hour or a couple hours driving, there was nothing but burnt out forest. And it looked like as far as the eye could see, and
it was probably one of our experimental burns.
Anyway, it seemed pretty big when I was driving along, and maybe it's not so big from an aerial view. I would assume that after something like that, the probability of a forest fire in that area the following year is probably pretty low.
Yes.
So, for how many years, like, do you get that break in
Right.
fire probability? Like, is there a danger of fire 5 years later or 10 years later, or how many years do you need for a forest to rebuild itself?
Typically, we kind of say 10 years. But what's happening is after the fire, you've got a blanket of kind of like black soils. It's not going to be flammable for another couple of years. Then the lighter fuels are going to start coming through, all the grasses, all the herbs and whatnot. So it will become flammable again within just a few years. But it's not going to be a very intense fire if it does ignite. Typically will take 10 to 15 years for the trees to start to build, grow back in to create a truly kind of flammable forest again, which is something for people in localities like Kelowna and whatnot to keep in mind. Yes.
Mountain pine beetle. First of all, what's going on with that these days, and secondly, is the dead zone, as it were, is that factored into some of these fuel maps at all? Is there any way of kind of incorporating, massive stands of dead trees into fuel modeling?
The status of the mountain pine beetle, I'm probably not quite in a position to answer that. I know that it certainly had a large impact on BC. There is much talk about it moving into Alberta. Exact details, I'm not too sure. My feeling, I think, is that it's actually starting to subside in BC, but
there's nothing left to go, right?
Yeah, well, I've seen maps where they show the mountain pine beetle spread. It's like a big atomic bomb that's kind of, or a tsunami of forest that's kind of being affected as this wave propagates out. Certainly, it's described as a specific fuel type for the people in British Columbia. The British Columbia, well, it used to be the Forest Service. I forgot what they've been renamed to. They're well aware, and they tried to account for this. Unfortunately, we haven't been able to conduct experiments to validate, the best fuel type to use to represent these forests, but they are kind of just assuming a bit of a worst case scenario. We'll go with this fuel type. So it is taken into account, yes. And indeed, I'm working with people that are trying to model these fuels because we can't seem to get the experimental burns in that we want. We're actually conducting some modeling experiments with supercomputers to try to figure this out. Anything else? Yes.
I'm just having trouble processing one thing on your charts.
Okay.
So in April and May, fire and Manitoba are not the two words that come with Manitoba in the spring.
Yeah, you're thinking floods.
To my mind.
Yeah.
So the optimistic point of view is if you're predicting fire, there's a flood guy out there saying that there won't be floods in Manitoba this spring. Is there, in your maps, in your prediction, is there a tie to the Red River height and the flood season? And do you you're using the same models, I assume?
Yeah, the flood zone of Manitoba is pretty small in comparison with the size of the red area on that map.
Is Manitoba facing much of a flood situation?
Not this year.
I don't know, but I would guess that it's not. I mean, this is dependent a lot on not just the how quickly the temperature changes, as well as snowpack. I don't think there was much snow in
a lot of conditions down in the U.S. as well.
Yeah, because this is coming mainly down the Red River from the Dakotas and whatnot, isn't it?
My follow-up question is,
Yes.
The U.S. fire map that they put out.
Yeah.
Do you talk to them, and what's your relationship to the U.S.?
I'm talking to them next week.
Give them our love.
Huh?
Give him our love.
Oh, okay. We have been, this is what got me involved in this in the first place, was the Americans, the U.S. Forest Service and various other people invited Canadians to come down to help produce a North American prediction. So that what got me involved in seasonal forecast to begin with. Since then, they've held annual meetings where they've kind of combined all the meteorologists in the U.S. doing fire weather forecasting, together with ourselves and some Mexican government, and to produce this forecast. There may be a move away from just doing one in the spring to doing monthly kind of meetings, monthly updates. But yes, to answer your question, yes, I have been working with the U.S. on this stuff.
And I have one last question.
Yes.
So with these maps and your forecast from a question earlier, you give these to the provincial fire management agencies, and there's another discussion that's going on, just to make sure I understand this, about who needs to be ready and who needs to be ready to share, and where do you park the trucks, and the status of which provinces are in high alert for the season or not. Is that the next step with these maps and what happens?
At this stage, the provinces are just looking at these maps and keeping them in their back of their minds. These are not, as far as I know, they're not using these to make big decisions. But I would hope that they're looking at these and kind of keeping them in the back of their mind. It depends. Each of the provinces is slightly different. Some think that predicting beyond 3 to 5 days is a waste of time. Others think that, this is something we need to do. So there's varying opinions. But I'm finding that now that I've begun doing these, my maps are starting to appear in various kind of internal reports. Sorry?
From a provincial point of view.
From a provincial point of view, I'm starting to see these maps popping in. Not so much as CFS says this is going to happen, so we better drop everything, as much as this is what one model's saying, this is what another model's saying, and this is what the Canadian Forest Service is saying. So they're all kind of looking at all the various predictions as tools. Mm-hmm. And I would hope that they're becoming more and more incorporated in kind of long-range planning. But at this stage, I can't say with certainty who's using these things and to what degree they're using them. Any other questions? Looks like everybody's questioned out. Okay, well, maybe at this stage I'll politely say thank you again for inviting me. I've enjoyed this opportunity. I hope my predictions, perhaps from doesn't turn out. From scientifically, I hope it turns out. But we're always going to have bad years and good years. But the way this is pointing, it's looking like this might be one of those bad years. We'll see. I'm putting my neck out on this, and hopefully a month from now when it starts raining, you'll have forgotten. Okay? Thank you very much.
Thank you.